Section 5.5 is performing function operations. So example 1 is let f of x equal 5 root x and g of x equals negative 8 root x. Find f plus g of x and state the domain, and then we'll evaluate the sum when x equals 16. So if we're finding f plus g of x, that just means that we have to add f of x and g of x. So that's just f of x plus g of x. So we'll take f of x, or we'll say f plus g of x is equal to 5 root x for f of x, and then plus g of x, so either plus negative 8x or just minus 8x, or 8 root x, excuse me. And then we have the same number inside the radical, so now we're just subtracting the coefficients. So 5 minus 8 is negative 3. And then that root x just kind of tags along. So f plus g of x is equal to negative 3 root x. And then if we want to figure out or evaluate the function when x equals 16, we're finding f plus g of 16. And that just means that we're substituting in 16 for x and evaluating. So it's going to be negative 3 times the square root of 16 instead of the square root of x. So negative 3 times the square root of 16 is 4. And then negative 3 times 4 is negative 12. So f plus g of 16 equals negative 12. And then for the domain, so the domain is just asking like what x values can I substitute in order and still get a real number out. So it doesn't have to be like a pretty number, just a real number out. So in this case, since we have a x inside of the radical, we can't have a negative inside the radical and still get a real number out. So my domain has to be at least 0 or any positive number. So the domain just can't be any negative number. So it's going to be x is greater than or equal to 0. So it can be 0, it could be any positive, but as soon as it turns into a negative, we don't get a real number out because it's inside the radical. For example 2 says let f of x equal 2x cubed. This should be a plus 4x squared minus 8x plus 4, and g of x equals 3x cubed, minus 5x squared, and then this should be a plus again, plus 6x minus 9. And we want to find f minus g of x and state the domain, and then evaluate the difference when x equals negative 1. So same idea as before, like f minus g of x is the same thing as f of x minus g of x. So we just have to take f of x and subtract g of x. So f minus g of x is going to be f of x, which is 2x cubed, plus 4x squared, minus 8x plus 4, and then minus, in parentheses, since we're subtracting all the terms, g of x, so 3x cubed, minus 5x squared, plus 6x minus 9. So we can distribute the negative, or you can just make sure that you remember that you do take away everything inside the parentheses. So either distribute the negative and come off and take the parentheses off, or just make sure that you're really careful about these 4 terms. So if we do combine like terms, 2x cubed, and then we're taking away 3x cubed. So 2x cubed minus 3x cubed turns into negative x cubed. And then 4x squared minus negative 5x squared turns into 4x squared plus 9x squared, or plus 5x squared. So that's 9x squared. And then negative 8 minus 6x, negative 8 minus 6 is negative 14x. And then a negative, or 4 minus a negative 9 turns into 4 plus 9, so plus 13. So f minus g of x is negative x cubed plus 9x squared minus 14x plus 13. And then if we want to find the domain, that's just asking what possible x values or what are all the x values that get us a real number out. So what can we plug in for x and get a real number out? Since we have like no x's in the radical or anything like that, our domain is all real numbers. And then for evaluate the difference when x equals -1, we're finding f minus g of -1. That just means that -1 is going into our function where x is, and we're simplifying. So this negative isn't being cubed right here, so we're going to leave that negative out in front, and then -1 will go in for x. So this will be -1 cubed plus 9x squared, so plus 9 times -1 squared minus 14 times x, so minus 14 times -1 and then plus 13. And then -1 cubed is still -1. -1 times -1 is +1 times another -1 is -1. But we have this negative out in front, so that becomes a double negative also, so we end up with +1. And then -1 squared is +1, so 9 times 1 is 1, so plus 9, or 9, sorry. And then -14 times -1 turns into plus 14, and then plus 13. So 1 plus 9 is 10, plus 14 is 24, plus 13 is 37. So f minus g of -1 is 37. And then example 3 says let f of x equal x cubed and g of x equals the square root of x. Find f g of x and state the domain, then evaluate the product when x equals 4. So f g of x, that's f of x times g of x. So we need to multiply the two functions together. So f g of x is going to be x to the third times the square root of x. So we have the same base, but in order for us to really multiply these two together, we need to change the radical to a rational exponent. So this is a square root and it has an exponent of 1. So if I want to rewrite this as a rational exponent, the x cubed will stay the same, and then the radical will be, the x will turn into my base, and then the 2 is going to be my denominator of my fraction, 1 is going to be my numerator because it's like b to the e over r, so it'd be x to the 1 over 2. And so now x to the third times x to the 1/2, we can multiply those two together because they have the same base. We just need to add their exponents. So 1/2 I'm going to change to 3, I'm going to change to 6 over 2 to get common denominators with the 1/2. And then we'll be able to add them. So f g of x equals x raised to the 6/2 plus 1/2. So that turns into 7/2. So f g of x equals x to the 7/2. And then when we're figuring out domain here, it's helpful to rewrite it in a radical form. Even if we don't write our final answer like that, seeing it in radical form will help us figure out the domain. So radical form, remember the base, the x, goes inside the radical. And then the denominator of the fraction becomes my root. And then the numerator of my fraction becomes my exponent. So for my domain, because I'm taking the square root of x, even if I'm raising it to the 7th power, it doesn't matter. Because I'm taking the square root of x, the domain has to be only positive, x value or 0, or an x value of 0 or positive numbers. It can't be negative. So my domain has to be x is greater than or equal to 0. So it just cannot be negatives, because if I have the negative inside the radical, it's no longer a real number, a real output. And then if we want to find f plus g of 4, or f times g of 4, It's also easier usually to evaluate it when it's in the radical form rather than the rational exponent form, so that's what I'm going to use as the radical form. So fg of 4 is going to be 4 inside the radical for x, the square root of that, and then we'll raise that to the 7th power. So the square root of 4 is 2 to the 7th power, and then 2 to the 7th power is 128. So fg of 4 is 128. And then example 4, let f of x equal 4x and g of x equals x to the 2/3 power. Find f over f divided by g of x and state the domain, and then evaluate the quotient when x equals 27. So you probably can assume that f over g of x is f of x divided by g of x. So f of x is 4x, so f over g of x is going to be 4x over x to the 2/3. So whenever we have the same base, we can subtract their exponents. So the 4 and the x, they aren't the same base together because they're not like being raised to an exponent together or anything like that. So I can think of this as just x to the 1st power or x to the 3/3 to get common denominators and subtract my exponents. So if I have 4 times x to the 3/3 over x to the 2/3, the 4 is going to stay the same, but to simplify the bases and the exponents, I have to subtract those exponents. So this is going to become x to the 3/3 minus 2/3. And then f over g of x equals, the 4 will stay the same, and then x to the 3/3 minus 2/3 turns into x to the 1/3 power. And then we can think of it as that, or we can rewrite it as a radical, because that'll make it easier for us to evaluate it also. So f over g of x equals, if I were to rewrite this as a radical, the 4 isn't being raised to the 1/3 power, so the 4 does not go inside the radical, it has to stay out in front. And then my x is being raised to the 1/3 power, so the x is going to go inside the radical. And then the denominator of my fraction is the root, so this is a cubed root. The numerator is the exponent, so since it's just the 1st power, I'm not going to write it, I'll just leave it like this. And then when we're figuring out domain, so usually when we see a radical, we think that the domain can't be negative, but it's okay to have the cubed root of a negative number because there's cubes that are negative numbers. Like, for example, the cubed root of -8, it's not no solution, it's -2 times -2 is +4, and then times another 2 is -8. So the cubed root of -8 would be -2. So anytime you have an odd root and an x inside that radical, the domain is going to be all real numbers. So for an odd root with an x inside the radical, it's all real numbers, but for an even root, x has to be 0 or positive. It can't be a negative number. And then if we want to evaluate the quotient when x equals 27, I'm going to use the radical form. So f over g of 27 now equals, the 4 stays out in front, and then we're finding the cubed root of 27. So the cubed root of 27 is 3, so this is 4 times 3, and then so f over g of 27 equals 4 times 3, so 12. So the next section is the composition of functions. So let f of x equal x plus 5 and g of x equal x squared plus 5x plus 3, and we'll find the following. So if we look at all of these, they all have like this little open circle. This is kind of confusing at first because it's not multiplication. So this is not like a raised dot little multiplication symbol. The little like open circle reads f of g of x. So it's kind of like if I were to rewrite it, like I can write it as f of g of x like that. It's the same thing. So think about like when we found up here like f plus g of 16. So because we're finding it of 16, 16 was kind of getting plugged into the function where x was. So if we're finding f of something or g of something, whatever we're finding it of is getting plugged into the function. So it's similar here. So if we're finding f of g of x, f of g means that we have to take g and we have to substitute it into f where x is. So f of g of x is we're gonna take g and substitute it into f of x where x is and then simplify it. So it's gonna be, instead of x, it's gonna be all of this. So instead of x, I'll replace it with x squared plus 5x plus 3. And then there's this plus 5 after. So plus 5. And then we'll combine like terms. We can combine the 3 and the 5. So it turns into x squared and then plus 5x. And then 3 plus 5, so plus 8. So f plus g of x equals x squared plus 5x plus 8. And then for b, it's g of f of x. So this time, instead of subbing in g into f, we're subbing in f into g. So g of f means that f is going into g where x is, but g has 2 x's, so it has to go into both places. So g of f of x is going to be g of x, but everywhere there's an x, I'm going to substitute in the x plus 5. So this x squared is going to turn into an x plus 5 squared, and then this 5x is going to turn into 5 times x plus 5, and then plus 3. And then from there we'll have to like FOIL the x plus 5. So this x plus 5 squared means x plus 5 times x plus 5. So when we FOIL it in the next step, x plus 5 times x plus 5 turns into x squared plus 10x plus 25. So x squared plus 10x plus 25 from the x plus 5 squared, and then plus 5 times x, so plus 5x, plus 5 times 5, so plus 25, and then plus 3 at the end. And then we're ready to combine like terms. So there's my only one x squared term, so the x squared will stay out in front. And then 10x and 5x is 15x. And then 25 and 25 is 50, plus another 3 is 53. So g of f of x is x squared plus 5x plus 53. Okay, and then f of x is where it gets really weird. So f of f means that we have to take f, which is x plus 5, and plug it in for x right here only. So it would be like f x plus 5 in where x was originally, but then after that we still have another plus 5, so plus 5 right here. So like f originally was x plus 5, but we had to substitute that x plus 5 in for x, so x plus 5, and then plus the other 5 that was originally there, and then we can just combine like terms, so the 5 and the 5 turns into x plus 10. So f of x is x plus 10. And then for f of g of 2, we already found f of g, so now if we're finding it of 2, we just have to sub 2 in for x. So we found f of g up here was x squared plus 5x plus 8. So instead of x squared, I'm going to substitute in 2. So it's going to be 2 squared, and then plus 5x, so plus 5 times 2, and then plus 8. And then 2 squared is 4, plus 5 times 2, so plus 10, plus 8. 4 plus 10 is 14, plus 8 is 22. So f of g of 2 is 22. And then g of f of 2, we already found g of f. It was this one up here, the x squared plus 15x plus 53. So if I'm finding that of 2, I just have to sub in 2 where the x is and simplify. So x squared becomes 2 squared, 15x becomes 15 times 2, and then plus 53. And then 2 squared is 4, 15 times 2 is 30, plus 53. And then 4 plus 30 is 34, and then plus 53 gets us to 87.